factoring out a monomial. So in the last section, we talked about how to find the greatest common factor, and I actually went to the next step, which was factoring out the monomial, but you do have some problems where you're just finding the greatest common factor by itself. So in this one, we'll go ahead and do both steps like we were supposed to do. So finding the greatest common factor, we look at our coefficients. Those are the constants. We have a 4, 24, and an 8. So what's the greatest common factor? Well, the greatest factor for 4, of course, is 4. 1 and 4. Will that go into 24? Well, yes. 6 times 4 is 24. Will it go into 8? Well, yes. 2 times 4 is 8. Now we look at our variable terms. We got an x to the 5th, we got an x cubed, and we have an x. So we at least have an x in everything. So then our greatest common factor, GCF, is equal to 4x. So to factor out everything, we'll start off with 4x, open our parentheses, and then we'll just divide everything by 4x. Fours cancel. The x cancels with one of the x's on top. It leaves, instead of having 5 x's, we have 4. And then here, so I'll go ahead and say we just have x to the 4th. Okay, we have negative 24 divided by 4x. Okay, so we'll bring down our negative. 4 goes into 24 6 times, and our x gets rid of one of the x's up top, so we just have 2. So we have 6x squared. We have 8x divided by 4x. 4 goes into 8 2 times, and the x's cancel. And this is positive, so we have plus 2. And so that's it. And we got the same answer that they have. Okay, so they give you a word problem where you have a helipad and you have the square region and you have a circle inside, and they want you to tell the area that's shaded. And what this is going to be is the area of the square minus the area of the circle. The length of the square is 2x and the radius of the circle is x. So the area of the square is the side squared. And that's not a coincidence. A square is a shape whose area you can find by squaring one of the sides. Okay? So we can put in 2x for s for the side, because that's the length of that. And then you distribute that exponent over the 2. So 2 squared is 4. And x squared is x squared. So we have 4x squared. And then the area of a circle is pi r squared. There's a joke where you can remember this. A young man came home from school one day, and his dad asked him, "What did you learn?" And this boy said, "I learned pi r squared." And the dad said, "What are you learning in school? Everybody knows that pi's are round." Well, pi r squared is the area of a circle. So if we substitute x for the radius r, we have pi x squared. So the area of the square minus the area of the circle is 4x squared, the area of the square, minus pi x squared, the area of the circle. So, how can we simplify this? Well, what we have in both cases, okay, the constant here on this side is a 4, and the constant here is pi, which is 3.14157. We're not going to write it out. So there's not any any common factor between 4 and pi. So the only thing you can factor out is the x squared. So if we say x squared, open parenthesis, because we're going to divide both of this by x squared, and the x squareds will cancel out here and here, and we'll have inside the parentheses 4 minus pi. And you flip over to the next page and you see they get the same thing. X squared times parentheses 4 minus pi. So that's how you solve those area problems. A circle inside of a square or a square inside of a circle. If it's a square inside of a circle, then the reverse would be the pi x squared minus the 4x squared. So you just got to know what's going to be inside of what.